First of all, I am taking the numbers which are ending in 1. Now, suppose I have an example of 31 square, right? So this number ends in 1, right? So it is 1 more than 30. So what am I going to do is, I am going to apply the identity for a plus 1 whole square, where a is the base number. So in this case, if this is 30 plus 1 whole square, then the value of a is 30, right? So this is the application of what am I doing on the left hand side here. Now I know that a plus 1 whole square, the identity is a square plus 2a plus 1. So I'll just split this 2a as a square plus a plus a plus 1. Now I know that the value of a is 30. So if I put a as 30 in this expression, I'll get my answer. So this is practically a plus, so I'll write it in another bracket so that you understand it in a better manner. See, if I take a as 30, I just have to do 30 square and add what? This is 30, and what is a plus 1? It is the number itself. 30 plus 1, that is 31. So if I have just 900 and I add 61 to the result, I'll get my answer 961. So what is the trick here? I am actually applying the identity a plus 1 whole square without realizing it. So if I tell you the short trick, it is take 1 less than this number, it is 30, and just square 30 and add the sum of 30 and its consecutive number 31 to the result, you will get your answer. I hope you understand the logic here. We will be applying this trick directly in our subsequent slides. Likewise, if you have numbers ending in 9, say if I am talking about 39 square, so I know that 39 is 40 minus 1 square, right? So unlike here where I took a plus 1 whole square, now I have to take a as 40, and that will give me the identity a minus 1 whole square. So I know that the identity a minus 1 whole square is actually a square minus 2a plus 1. I'll split the middle term again. This will give me a square minus a plus 1. So again a square, just like here we had a square, but what do we have now? So there is a minus sign. I'll go for a bracket. Here we have a as the first term, and then minus is taken out as a common factor, so I'll take plus here, and what comes next is pretty obvious. If you take the common factor out, minus out, you will be left with a minus 1 in the bracket. So what do you have to do here? So if I have a as 40, then I can find 39 square by putting a as 40, so 40 square, right? So I am finding 39 square using this identity now. Minus what? The sum of a, which is 40, and the predecessor, that means the previous number, a minus 1, which is 39. Now it's very easy, 1600, and subtract what? 79, you get 1521 as the square of 39. So the trick works very well. Any number ending in 1, what do you have to do? The number ends in 1, so you will take the base number a as, like here we have 31, so we took the base number as 30. So just do 30 square and add the sum of 30 and 31 to the result. If the number ends in 9, then take a as the next number, that is 40. So in this case, just take the square and subtract that sum of the number and its successor, right? Now let's see whether we can apply this trick to find the squares of big numbers. So first of all, I'll take some examples of numbers ending in 1, and now you will see, if you forget all these steps, you just know the last step, how quickly you can find the square of such numbers. The first example I am going to take up is the square of 81. So in this case, A is 80, right? Very close to 80. So I will do 80 square and add what? Add 80 plus the next number 81 to the result. So 80 square is 6400, that is obvious. I add what? 161 to this and I get 6561 as the square of 81. Now you can see how much time did I take to apply the trick, but this is the thing which requires a logic, and this is a rather an outcome of the a plus 1 whole square identity. Let's have some more examples. Can we take 131 square? Now this is very close to 130, so I'll take a as 130. So 130 square and add what? 130 plus the next number 131. So 13 square is 169, so followed by 2 zeros, and add 261 to the result. You get the answer 17. See, 61 will retain its place. 9 plus 2 is 11, so 1 carry, and then you have 17. So 17161 is the square of 131. We can take big numbers also, like let's take 271 square. So you have to do 270 square and add what? 270 plus 271 to the result. So 27 square I know is 729, 00, and since I have to add this, just add this first. This is 270 plus 270 is 540, so 541. Write it here and then write the result directly. This is 73441, which is the square of 271. Can we do one more question? Let's take 451 square. So 450, right? So 450 square plus 450 plus 451. Now since I have to do 450 square, I should know little bit of Vedic maths also. How to square numbers ending in 5? 4 5s are 20, followed by 25, and since it is ending in 0, so we will have 2 zeros, and 450 plus 450 is 900, so 901 to be added to the result. You get 104302. So 203401, it is the square of 451. See, when you have understood the logic, application part is really important, so that you can skip steps and you know why you are skipping steps, right? Okay, now let's take some examples of numbers ending in 9. So I'll take 4 examples and I'll show you how the trick works so wonderfully well for numbers ending in 9 also. The first example is that of 79 square. So very close to 80. So I have to do 80 square and subtract the sum of this number 79 and the next number 80. So 8 is 64, right? 6400. Now subtract what? 80 plus 80 is 160. So 1 less than that is 159. Now carry out the subtraction. You get 1, you get 4, you get 2, and you get 6. 6241 is the square of 79. Likewise, say a 3-digit number 149 square. So 150 is the nearest base. So 150 square minus 149 plus 150. Now I know that 15 square is 225, so it is followed by 2 zeros. And when you add these two, 300 minus 1 is 299. And so your answer will be, I have to subtract this. So you should always remember, we are subtracting here, and on the previous slide we added. So this becomes 1 and then a 0, and then 4 minus 2 is 2, and then a 2 and a 2. So 22201 is the square of 149. Let's take more larger numbers, say 239 square. So very close to 240. So we'll do 240 square and subtract what? 239 plus 240. Now 24 square is 576. So 00 and subtract 240, the double is 480. So 479 from this. So you get 10 minus 9, 1, 9 minus 7, 2, 5 minus 4, 1, and then we have 7 and 5. 5, 7, 1 to 1 is the square of 239. If you extend the method to larger numbers, 549 square, the calculations become a little bit more, because you have to find the squares of 2-digit numbers. So there are so many videos on the channel in which I have already told you how to square numbers from 11 to 99. So watch those videos, and these squaring will not be a problem for you if you watch and apply those here. So 549 square very close to 550. So I'll do 550 square and subtract 549 plus 550 from this. So square of 55, 5 6 are 30 and 25 followed by 2 zeros, and subtract, this is 1100. So 1099 from the result. So 10 minus 9, 1, 9 minus 9, 0. So this becomes 4 and this becomes 103. 301, 401 is the square of 549. Let's take the square of 76 and try to understand how this trick will work. As you can see, this 76 is how much less than 100? It is 24, right? So I am writing a 24 itself. So let's have 100 minus 76, and that gives us a 24. And when you get this 24, you should know that the square of 24 is 576. I keep on telling to my students, you should know squares up to 30, and that is why I have taken this limit. 30 less than 100 is 70, because remembering the squares beyond 30 is a difficult task. That is the reason. So 24 square is 576. I'll come back to this later. Now this number 76 and the deficit, that is 24, if you take the difference of these two numbers, you will get what? This is 2 and 5, 52, right? Just write this 52 and write this number 576. Retain 2 digits from here and carry forward the hundreds place 5. So 52 plus 5 is 57, and now pick up the calculators and check, is the square of 76 5776? I think you will be surprised. So let's have another example. 83 square. So 100 minus, right? So I have to do 100 minus 83. That gives me 17, and now you will see how you develop speed when you start practicing these questions. So 17, now 17 square is 289. It's a 3-digit number. So I'll leave it here as of now. And now these two numbers, just subtract 83 and minus 17. So how much is that? 83 minus 17 gives you 66, right? And now write 66, write 289, retain the 89, carry forward this 2, so 68. So 6889 is the answer. Now you can see I have consumed less time, and most of this is mental maths. This is not to be written, okay? Let's have a number in 90s now. Can we do 94 square? So again do the same thing. See, I will increase the speed now. 100 minus 94 is 6, and 6 square is 36. It is a 2-digit number, makes it easier for me. Now subtract like this. 94 minus 6 is 88. So where is the answer? 88, and 36 is a 2-digit number, no carry, nothing. 8836 is the square of 94. Now pick up the calculator and check all these. If you get it right, we can move on to the numbers which are more than 100. Let's see this. The first number I am going to take up is 108 square. So you can see here, this is 108, right? So whenever you have a number which is more than 100, how much is 108 more than 100? It is 8 more than 100, right? So I will add that excess to the number itself. So 108 plus 8, that gives me 116. Now this forms the first part, and the second part is this excess quantity square, that is 64, and just write them together, 116 and 64. Since we have 2 digits here, so the answer is direct. 11664 is the square of 108. Suppose we get 3 digits here, retain 2 digits and carry forward the hundreds place. Okay. So let's take a question where probably we have to do some carry forward. So let's do 113 square. So I told you the same number plus the excess over 100. This is 13. So how much is this? This is 126. Now this forms the first part. And the excess is 13, right? So 13 square we all know is 169. So now you have to write this square number later and the first number here, 126 and 169. Retain 2 digits, carry forward the hundreds place, so 126 becomes 127 and that gives you the square of 113. Likewise, we can take one more example, 124 square. So 124 and the excess 24 gives you 148. That will be my first part. And excess is 24, so 24 square is 576. This is my second part. Just write them together, 148 and 576. Retain the 76, carry forward the 5. 148 plus 5 is 153, and there we go. The square of 124 is 15376. Let's take the example of squaring 197. So I know that this is very close to 200, right? So makes my task all the more easier. So I'll write 197 times 197 and I will try to convert one of these numbers into the base number. So if I add 3 to this, I'll get a 200. Now, so what do I have to do? I have to do the balancing act. Now, what is the balancing act? Balancing act is when I have added 3 to this number, I have to subtract 3 from this number. So what do I get? I get 194. Now multiplying 197 and 197 is tricky, but multiplying 200 and 194 is easy, right? Why? Because we have 2 zeros here and 2 times 4 is 8, 2 times 9 is 18, so 8 and a 1 carry, 2 times 1 is 2 plus 1. 3. So 3800, is that the answer? Not at all. We have one more step coming up. What is to be added to this? How much this number, when you converted this number to a base number, how much did you add or how much did you subtract? 3, right? So just add 3 square to the result, and 3 square happens to be 9. So just add 9 to the result and now watch the magic. 38809. Pick up your calculators, friends, and check 197 square. Is that 38809? And you are really going to be amazed and surprised. Oh, does it work for all numbers near the common base? I'm going to prove it to you right now. So I'll take one more number very close to say 200 only, but this time it will be more than 200. Okay. So how about taking 206 square? So this is 206 times 206. Perfect. Now if I reduce this by 6, this will become 200. But in that case, I'll have to increase this by 6. This becomes 212. Now multiply these two. 0, 0. 212, the double is 424. And what to add to this? This number square, that is 36. And now 4 to 4, 36 happens to be the square of 206. And now these are the things which take place in mind, and this is the beauty of mental mathematics. When somebody else shows it to you, you will feel like, oh my god, so many steps are there in this. But when you do it yourself, you realize this is not that bad, right? Okay, let's see another question. Can we take a number very close to 300 maybe? Okay, 307. Let's take 307. So 307 times 307. Reduce this by 7, you get 300. And reduce, I think I've already reduced, so I have to increase this by 7. This gets me 314. So 0, 0, and 3 times 4 is 12, 2, 1 carry, so 4, and 3 times 3 is 9. Add what? 7 square, 49 to the result, you get 9, 4, 2, 4, 9. There we go, 9, 4, 2, 4, 9. That is the square of 307. Now I'm being very smart, right? I'm taking numbers which are very small and they can be multiplied directly also. Let me show you the beauty of this trick by taking higher numbers. Suppose I have 491 square. So 491 times 491. See, I am going to speed up now, okay? So if I increase this by 9, this becomes 500. So I have to reduce this by 9. So 491 minus 9 is 482, right? So double zero, 5 twos are 10, 0, 1 carry. So 5 eights are 40, 41 means 1 and 4 carry. 5 fours are 20, 24. 2, 4, 1, triple 0. Add what? The square of 9, 81 to the result. You get 180,142. 241081. That is the square of 491. Whew. Easy, right? It's getting easier. Give me a thumbs up. Come on. In the comments, you need to tell me whether you have seen this trick before or not. And if you have not seen it and you are not sharing it, that's not done, friends. Come on, you got to share it, okay? Wow. So let's take another number. Say 889 square. Now see, I am increasing difficulty for myself and I'll test myself whether I can actually do this or not. So 889 times 889. So if I add 11 to this, this will become 900. And if I subtract 11 from this, this will become 878. 878, right? Now multiplication. So 0, 0. 9 eights are 72. So 2 and a 7. 9 sevens are 63. 70. So 0 and a 7. 9 eights are 72 and 7 79. So 790200. 11 square is 121. So 1, 2, 3, 0, 9, 7. Pick up the calculators now and let me know in the comments. 790321. Is my answer correct? Because this is a live demonstration. Live recording is going on. I am testing myself also whether I can actually do justice with this method or not. Okay. This is not done, friends. Yet, you know, even if I practiced 50-60 questions and I am doing it live here, yet I am feeling that I need more practice. So that's what mental maths is. More the practice, more the confidence. Okay. Now I am going to test myself with 4-digit numbers. Let's go. Here we have a number 1208 square. So 1208 times 1208. When I reduce this by 8, I get 1200. And when I increase this by 8, I get 1216. Now the multiplication part. So I know the 12 times table. So 0, a 0, 12 6 are 72, 2 and a 7. 12 ones are 12, 19, 9 and a 1. 12 twos are 24, 25, 5 and a 2. 12 ones are 12 and 2, 14. So 1459200. Add what? The square of 864 to the result. My answer is ready. 1459264. Wow. And I don't think I have that much confidence. You know, I think this will be correct. So let's take another one. Big number. 1493 square. Very close to 1500. So 1493 times 1493. Increase this by 7. I get 1500. And reduce this by 7. I get 1493 minus 7 is 86. Right? Now, 2 zeros. Perfect. 15, 6 are 90, 0, 9. 15 eights are 120, 129 means 9 and a 12. 15 fours are 60, 72 means 2 and a 7. 15 ones are 15 plus 7, 22. So 2, 2, 2, 9, 000 and 7 square is 49. That will give me my final answer 222949. That is the square of 1493 square. The only thing is you should know 15 times table well work. So let's see the simple example of 29 square. So the trick uses the numbers 25 and 50. So the use of 25 and 50 is very, very important in the squaring of numbers, like 2-digit numbers. If you go in 3-digit numbers, it's going to get complicated. But you can use the trick all right, but it will get complicated. Okay. So I'll stick myself to only 2-digit numbers in this video. 25 and 50. How do we use these two numbers in squaring of any 2-digit number? The first step is just have the difference of 29, the number here, and the first number which I have taken here, 25. The difference happens to be 4. And the second step is because this number is less than 50, so I will subtract this number from 50. So 50 minus 29, this happens to be 21. Now if I know the square of this number 21, then my job is done. So it is expected that you should know squares of numbers up to 25 at least, right? So 21 square is 441. But remember, the number I got here and the number I got here, I'll use these two numbers to find the final answer for my question. From this part, I will retain 2 digits in the answer, and if there is any more digits here, just carry forward and add it to the previous number. So 4 plus 4 is 8, and there we go. The square of 29 is 841. So at the first instance, when you see the trick, it is like, why not do 29 times 29 directly? Yes, obviously we can use the traditional approaches, but learning new things enables you to experiment with numbers, and that's what makes you smarter. Let's take one more example of how about taking 37 square. So if I take 37 square, 37 minus 25, the first number here, it gives me, this is 12, right? And how about 50 minus 37? I'm getting closer to very small numbers here. See, this is 13, and 13 square we already know is 169. So how will I use 12 and 169 now? I will retain 69 from here and carry forward the 10, the 1 here, sorry, and the 1 makes this 12, 12 plus 1, 13, so 1369 is the square of 37. Now you must be feeling better now, right? Let's see one more question, and you will see as we get closer to 50, the process becomes so much simpler. See, 48 square. Now if I do 25 subtracted from 48, I will get 23, right? And if I do 50 minus 48, I get 50 minus 48, which is 2, right? Now 2 square, the number here is 4, and so I will write this number as 04, because I told you I have to retain 2 digits from the second part. So 04 and 23, nothing carried over, so 2304 is the square of 48. Now you can check using the calculator and you will see how effective the trick is. Let me take some more examples where I take numbers above 50 now. Suppose I have a number like 56 square. So the first step is 56 minus 25, and that gets me a 31. The second step is, now this is more than 50. So I will do 56 minus 50 now. I don't want a negative number. So I'll subtract 50 from this number. So this gives me 6, and 6 square is 36. Now see, 2 digits here and 2 digits here. The answer for the question is 3136. You can write it directly, no problems at all. Let's have some more examples. Suppose you have to take 64 square. So 64 square, 64 minus 25 happens to be 39, right? And if you subtract 50 from 64, you will get 14, and 14 square is 196. Now here we have 3 digits, so I told you I don't want 3 digits here. I will retain the last 2 digits, and this will be added to 39. So 39 plus 1, 40, and there we go, 4096 is the square of 64. See, we can go on and demonstrate so many tricks, but practice is what is required, and slowly the timing is getting reduced, and the number of steps I am writing, they are also getting reduced. So what some more examples? 71 square. So first thing is 71 minus 25. Second thing is 71 minus 50. Now these are the two numbers which you have to get initially. Now if I subtract 25 from 71, it's 46, right? And if I subtract 50, you have 21, and you should know 21 square is 441. Now what is the answer? 41 retained and 4 added to 46 gives me 50. So 5041 is the square of 71. Let's take a more larger number. Let's see 82 square. So if I subtract 25 from 82, I will get 57. And then if I subtract 50 from 82, I get 32. Now finding 32 square can also be done using the same trick which I have demonstrated in my next question. Okay, so as of now 32 square 1024 I am writing directly. So 24 retained and 10 added to 57 gives me 67. So 6724 is the square of 82. Now let me take a question where the problem is of finding the square here, not here. So I will use the same squaring trick twice. Let's say 93 square. So if I do 93 minus 25, this will give me one of the numbers, and that is I think 68 if I am not wrong. And then 93 minus 50 is 43, and I need 43 square now, because without that I can't find the answer. So for doing 43 square, I'll do the same thing again. If I subtract 25 from 43, I get 18, and 50 minus 43 gives me a 7. So I'll write it as 707, and the square of this is 49, which is a 2-digit number. So if I get a 2-digit number, the problem is resolved. 1849 is the square of 43, which I will write here, 1849. Now retain 2 digits, 49, and this 18 will be added to 68. That gives you 86, right? So 8649 is the square of 93. So if I say, suppose there is a number like 73 and I need to find the square of 73. So let's break up like this 73 into two parts, wherein we have 73 written as 70 plus 3. And so 73 square is actually to be written as 70 plus 3 whole square, right? Now if I assume this number 70 as a and plus 3 is obviously there, then I can apply the identity and expand this. So a plus 3 whole square will be a square plus twice of a times 3 and plus 3 square, which is a square plus 6a plus 9. And this is the short trick which I am going to use for squaring the numbers ending in 3. A square plus 6a plus 9. See how this works now. Suppose I have to square 73. So I am applying it for the same number here, 73. A square. Now a square, just forget this 3. This is 7, right? And I know that 7 square is 49. So I did a square. And then 6a, 6 times 7 is 42, and finally we have the 9. In order to add them, the unit digit 9 will come as it is. 42, retain the 2 and carry forward the 4. So 49 plus 4 is 53, and now pick up the calculators and check, does this short trick a square plus 6a plus 9 work, and is the answer 5329 correct? And you will be amazed, by seeing that how much time you will be consuming in squaring 2-digit numbers ending in 3. Let's take one more example like 93. Okay, so a square, 9 square is 81. 6a, 6 times 9 is 54, and finally the 9. So the 9, 54 means 4. 5 carried, so 81 plus 5 is 86, and here you have the answer 8649. So where from I am getting these steps? I am getting these steps through a logic. So in mathematics there is a logic for everything, and nothing works without any reason. So let's see, can we apply this trick to square 3-digit numbers ending in 3, like 123 square. So apart from the 3 here, we have a 12. So in place of a single digit being called a equal to 9 here, a equal to 7 here, I will say a equal to 12. So I'll have to do a square, which is 12 square, 144. And then 6 times 8, 12 times 6 is 72. And finally the 9. So the 9, 72 means 2, the 7 carried, 144 plus 7 is 151, and here you have the answer 15129 is the square of 123. Now, does it work every time, or you need some special competencies, to get to the correct answer? Let's see in subsequent examples. Let's expand the trick to some higher numbers like 243 square. Now A is 24 and B is 9 obviously. So I need a 24 square, I need a 6 times 24, and finally we need a 9. So 24 square, if you don't know 24 square, you should know the short trick. If you know 24 square, which is 576, it's perfectly fine. In the next question, I'll be taking up number here whose square you still have to find. So 24 into 6 is 144, and finally we have the 9. So the 9, the 4 and this 14 gets added here, which gives you 590. So 59049 is the square of 243. Now what happens when this number here becomes large? We have an alternative for that also. Suppose you have to do 463 square. Now I need to know 46 square first. So to do 46 square, what will I do? 4 square is 16, 6 square is 36, and then multiply 4 and 6, you have 24. Double of 24 is 48. Write it in the middle and add vertically. 6, 11 means 1, 1 carry, 11 means 1, 1 carry, and a 2. That's how you find the square of 2-digit numbers. I again used the identity a plus b whole square here. If you have seen my previous videos, you will understand this. So 2116 is the first number I wanted, and after that I want 46 times 6, because it is 6a which I have to do here, right? So 6 times this. So 6 times 6 is 36. 6 times 4, 24 plus 3, 27. So 276. And finally we have the 9, and rest is very easy. 9, 27 gets added here, and the 6 retains in the answer. So this is 2, 1, 16 plus 27 is 43, and there we go. 214369 is the square of 463. Now you can go on and on, friends, and take much larger numbers, and you will see that the trick works wonderfully well for all numbers. Let's take one more example. 853 square. So I need 85 square now, and I know the square of any number ending in 5. 8 times 9 is 72, and this 72 has to be suffixed by 25. Any number ending in 5, the square will end in 25. So 7225 is the square of 85, which forms the first part. The second part is 85 times 6. So 6 5s are 30. So 3 8 6 are 48, 51. So 510 forms the second part, and the 9. So your answer is 9 0. The 51 gets carried forward. So this is 6 7 2 7. There we go. 727609 is the square of 853. I can extrapolate this to even 4-digit numbers. Let's take 1163 square. So I am taking different examples so that you can actually practice this using 2-digit, 3-digit, 4-digit, even 6-digit numbers. And if you have basic knowledge of squaring of 2-digit, 3-digit numbers, then 4 and 5-digit numbers will not be a tough job. Let's see this one. So apart from the 3, we have 116. So I need 116 square first. How do I do that? 11 and 6. 11 square is 121. 6 square is 36. 11 times 6 is 66. And double of 66 is 132, which I will write in the middle here. Add vertically, you get a 6, you get a 5, a 4, a 3 and a 1. So this is the square of 116. So I need this as the first part. 1, 3, 4, 5, 6. Now how about the second part? This 116 is to be multiplied by 6. So 6 6 are 36. So 9 and a 6. So we have 696 as the second part, and the third part obviously is the 9, because the number ends in 3, the square will end in 9. Start writing from the unit digit 9, 6, and what happens to the 69? It gets added here. So this becomes 15, 5, 1 carry, 12, 2, 1 carry, then we have the 5 and the 3 and the 1. So 1, 3, 5, 2, 5, 6, 9 is the required answer.